fractions, decimals, and percents, and in problem applications. So what's different today is your percent bars are more challenging, meaning that it's harder to see what the shaded part is. So, but I bet you could give really good guesses. Okay, so give me a guess, Echo.
2/3.
Okay, 2/3. Kate, give me a guess of the red region. 4/6. That's 2/3. Isabella? You'd say 2/3, Sean?
5/8.
5/8. Anyone else? One more guess. Okay. Let's see. So if it were 2/3, Isabella, how could you verify that you are, so you guys aren't up close, right? So those are decent guesses. Okay, so how would you check it? Like, what would you need to do to say, well, I really think it is 2/3, I'm going to show you. What would you do? If it was on your paper or you were going to explain it to somebody?
What I do is I find them out and I put it up with my fingers and then I move it over.
So what part would I be moving around, the red or the white? Okay, so let's go with her idea. We're going to take her white part, and she says she moves it around with her fingers. So I have the smart board here. I'm going to just trace the white part. And 2/3 was the first guess in the afternoon in the other class too. So she would then mark this off as my sense, right? How do you feel about that guess now? Not so good? It wasn't a bad guess from not sitting close to you're sitting back in the room and you're not touching it.
Wait, what was it?
Well, it's not 2/3. Do we agree?
Yeah.
It wasn't a bad guess, right? Because it kind of looked like 2/3. The thing that she did well, and the other kids that guessed thirds, is you really want to look at benchmark fractions. Usually if there's a problem like this, they're interested in benchmark fractions. So our benchmarks end in are halves and fourths and eighths and thirds and fifths. Okay, so it would make sense that 2/3 would be the only third benchmark that would make sense. But 5/8 is what Sean's saying. While I have that up here, could I get fourths out of this?
Yeah.
Yeah, you think this could be divided into fourths? So I'd have to go halfway, right?
Oh, wait.
Halfway would be right about here. Don't you agree? How do fourths look now?
No. Yeah.
Fourths? Really? That red part is fourths? The fourth line, 1/4, and this is 2/4. 3/4. I don't see that it's fourths. I think eighths was pretty good. Eighths was pretty good. So because you do this and then you've got this smaller jump, and it does look like you can divide these into eighths. Pretty good, right? So if we were going to really test it out, looks like I kind of look at maybe seeing if I could just sort of get this bit to fit pretty well, just that little bit. And I get about 8 of those. And remember, it should be really close. Not bad. That's pretty good, Sean. 5. That would be perfect as long as I get about 3 more here, right?
Oh my God.
Impressive, Sean.
You
Yeah.
go back there. I need you all my
Okay. Good job.
Give the man a sticker.
What were you thinking, Sean, when you saw that? How did you think 5/8? Because I would say that wasn't obvious. I'm saying, how did you guess that so well so quickly?
I was going to go with 3/4, but then I saw that would be a little oval.
So,
then I tried halfway between.
so you can just do that visually, not even touching the paper. Most people need to touch, right? So you have worksheets usually to do this on. And you can use patty paper. Good job. Okay. So we're going to take that today and we're going to extend it to percents. And it's kind of handy that we also spent the beginning of class um, with that review question of fraction to decimal. Because now I can look at these pages here, and we've got all of these decimals, right, for eighths. Okay, and so, and for fifths, but for 5/8, do you see the decimal is 625 thousandths right here? See that? We're going to change that to percents. And I know that some of you have learned that, but if I were going to put the decimal for 5/8, taking that from this board over here, if that's the decimal, what's the percent? Peter.
60.5.
Okay, and why?
Because
Put that away. Echo.
nothing can be over, nothing can be 100, or nothing can be over 100%.
Well, you could have 150% of something.
Well, yeah, but that's not like.
But not if this is one whole over here, right?
Yeah,
If the fraction is one whole,
you can't really have like 625.
if this is 100, if this bar represents 100%, this number right here, the 5/8 has to be surely more than 50, right? It's more than halfway. And it's less than 100. Okay, do you guys see that? So you're right, Peter, that's the way I would think of it. Now if you think about the place value, this is the tenths place, and this is the hundredths place, right? So if you could just look at any decimal and find the hundredths place, that is another way to write your percent, is just say, well, I know it's 62, it's a little more than 62 hundredths, but it's not quite 63 hundredths, so we say it's 62.5% or 62.5%. You get that?
Yeah.
Everybody? So down here, if I want to do fraction to decimal to percent, if I have a whole, when we do percent, we compare to 100, but when we compare to decimals, we're going to compare to 1. So fractions, you're going to compare a whole, percents 100, decimals 1. So Masani, what is this fraction right here? Right in the middle would be a half. So Carson, the decimal is
The decimal is
0.5, and then Isabella, the percent is 50, right? So if you think of this as tenths, hundredths, it's 50%. So if I have fourths, then what's the decimal for a fourth?
It is like 25.
25 hundredths, so what's the percent?
25%.
25%. Okay, so Echo, what's the fraction right here? You see that back there? What fraction goes right here? One what? Okay, and what's the benchmark, the decimal that goes with that benchmark fraction? Less than a tenth, right? I mean, less than 2/10. Use that technique of thinking of this as 250. It's halfway.
Please excuse the interruption. Teachers, if you could.
Not quite, Isabella. Wait, and Caden, is that right?
The decimal is 12.5%.
Okay, so 125, what Isabella said, thousandths is correct for the decimal. The percent is 12.5%, because this is the tenths place and the hundredths place. So after the hundredths place, for percent, you have to put a decimal. So Peter, what goes right? Let me shrink that up a little bit. So if this is 5/8 right here. and 7/8 here. Okay, what is 7/8 as a decimal and a percent?
That would be 8 point, or as a percent,
As
87.5.
because the decimal is
0.87.
0.875. And for 3/4, Sebi,
3/4 is 0.75.
7,500 and the percent,
75.
75%. Okay, and 5/8 we had above, 62.5%. Okay, that's part of your work today. So, I'm gonna pause that. So, this is basically problem number 1 on the worksheet, the very front page. And on the front page, you're gonna do all of problems 1 through 7. And then, when you turn the page, this east-west problem looks like this. This is what I want you to do to start with. This is problem 1 on the back. And you're going to go through 4 for homework. So first you have to read about the problem.
So 1 through 4 on this.
Yes, but I'm going to do 1 with you. So in order for me to do that, I want you to read the problem so we can talk about it. Okay, in your own words, Casey, tell me what the problem's about.
It's about the East Middle School and the West Middle School having a rivalry for the sports team.
Good. And part A, Isabella, what do you have to do for part A? Fill in the ratio table to do what? You don't have to fill the whole thing in if you don't need to. What are you trying to get to? 100 where? Where would the 100 have to be? In the total fans, and the word spectators. So this is 400 spectators. So in East-West, if we looked at a problem like the front page, if there was a bar graph of this, of the East fans, not a West fan bar graph, if this were an East fan bar graph, sometimes the bar graphs make a little more sense. If there's 400 people at the whole game, but only 160 of them are East fans. Do you get that?
Yeah.
Okay. But they want to get this whittled down, not to this situation. They want to say, what if there was a 100 here? And the reason is they want to ask you about what percent of the fans were East fans. So we know 400 fans were there and 160 of them were East fans. But the question is, part A is to get the ratio table to 100, and that's because percent is a comparison. What does it mean, Peter?
100%.
Yeah, like what does percent mean? What are you comparing to?
It means like you're comparing it to like 100.
Yeah, how much out of 100? It means like per 100, or it's a comparison like he says. You're comparing to a total of 100. So if I want to figure out what percent something is, I need to get my total, my whole, to be 100. So how are you going to do that, Kate? Catherine? And when you divide that by 4, Allie, what do you get? And up here, though?
160 divided by 4 is 40.
And
40 divided by 4 is
60. Okay, so then to answer, so part A was the work there. And part B, Allie, what's part B say?
what fans of basketball game for East fans?
So what would you say?
3% for
Right, 40% were East fans. And 60% were West fans. Okay, what's part C? Uh-huh.
What was the ratio of East fans to West fans?
Okay, so, okay. Okay, so what's the ratio of East fans to West forms in simplest form? So, Zoe, what's the ratio of East fans to West fans in this blue writing here? How would you say ratio of East to West? What would it be? It would be 40 to 60, not 60 to 40, because I said East first. Okay, can you get a smaller ratio, Zoe? 20 to 30. Can you get a different ratio? Let's see, what haven't I called on? Jasmine? Looking at this, can I divide down a little more? By what? No, like what goes into both 20 and 30? 10 or 5. How about 10? So if you divide by 10, they both do. Right? And so the most simplified ratio of East fans to West fans, Haley, would be what? 2 to 3. And you could write that like this with a colon, or you could write it like a fraction, or you could write it in words. But you guys, what kind of comparison is the percent? Part to part or part to whole? Sebi? Yeah, 40 per 100.
Oh, no, sorry, part to whole.
Yeah, percents are part to whole. This right here, I didn't even put the total in. I could. It doesn't matter. But the question on C is asking me a part to part. You should always be thinking about that. Is it part to part that I want? Or do I want part to whole? This is part to whole, right? Is there a D, part D there? No. Okay, so what if I had this question to you? This looks more like the front page, doesn't it? Even though they don't put this in here. This picture ties in with that. What's missing? Well, this is only a bar graph of what? It's got the total. What else does it have?
Percentage.
Has percentages of what?
100%.
It has percentages, but of all the information in this graph?
400%.
What's missing? What's this a bar graph of? Yeah, Carson. It's just about the East fans, right? It's a different way to give some information. And that percent was 40, right? So if I wanted to have a bar graph that represents this whole table, I would need 2 bar graphs, probably one stacked upon the other. You guys see that? But they could be related to give the same information. Okay, so your assignment today, when you look at this, you've got, my pages are sort of reversed here, because this comes first. So you have the first page where you're going to do problems 1 through 7. They're bar graphs. The second 2 sides, there's 4 problems. I just did number 1 with you. So you're going to finish 2, 3, and 4. Eventually, you should be able to do a problem like number 1 without the table given to you. You should be able to make the table yourself. And you have already done that this year on quizzes and tests. They're kind of reviewing for you. So you are not doing the entire packet. You're doing 3 sides. The first 3 sides. Any questions for me? So you have about 8 minutes to work on that in class. I'll post this video. I'll call it like fractions, decimals, and percents, school plays. I'll title it school plays.
We do the whole first class and